This video is about section 8.3, testing a claim about a mean. So in this section, we will conduct some hypothesis tests about population mean, which is mu. When we test for mu, there are two cases. One is the population standard deviation sigma is known. One is the population standard deviation is unknown. So when sigma is known, you will use z as your test statistic. But this case is very rare because if you don't know about your population mean, but you know your population standard deviation, it's really unrealistic and rare. So usually we don't see this case. What we will see more often is the second case. When you test for mu, your sigma is unknown. So in this case, we will use t as your test statistic. We'll look at one example here. This is a problem from your homework. In a test of the effectiveness of garlic lowering cholesterol, 64 subjects were treated with raw garlic. Okay, so here the first data appeared. 64 subjects were treated with raw garlic. So this 64 is your sample size. Right, your N is 64. Let's keep going. Cholesterol levels were measured before and after the treatment. The changes in their levels of LDL cholesterol have a mean of 0.1 and standard deviation of 2.44. So now we have some more data. First of all, this 0.1 is the sample mean. Use X bar to represent the sample mean, 0.1. And this 2.44 is the sample standard deviation. So S is 2.44. All right, keep going. Use a 0.05 significance level. Okay, now 0.05, this is the significance level. This is our alpha, 0.05, to test the claim that, so here's the claim. With garlic treatment, the mean change in the LDL cholesterol is greater than 0. So if you put your claim in symbolic form, it will be the population mean change is greater than 0. So the mean is greater than 0. That's the claim in symbolic form. So based on the claim, we can find our null hypothesis and alternative hypothesis. So remember, the null hypothesis is the one with the equal sign, always with the equal sign. So in this case, it will be mu is equal to 0. And the alternative hypothesis should be the same as claim because the claim doesn't have any equal sign in it, right? So my H1 is mu is greater than 0. Those are the hypotheses. So before I conduct this test, I need to see if everything satisfies the two requirements. What are the two requirements? First, your sample needs to be a simple random sample. So you can see here it says assume that a simple random sample has been selected. So this requirement is being satisfied. The second requirement is either your population is normally distributed or your sample size N is greater than 30. Okay, so if you look at the problem, it didn't say anything about the population is normally distributed, but our sample size is 60, right? N is 64. Our sample size is 64, which is greater than 30. So the second requirement is satisfied also. So since both of our requirements are satisfied, we can keep conducting the hypothesis test. Let's decide our test statistic. So as we know, we're testing for the mu, the population mean, and the population standard deviation is unknown, because if we read the problem, we didn't see anything about the population standard deviation. So in this case, the test statistic will be t. One way to do it is to use the formula. This is the formula for t. You could plug in all the corresponding values. For example, in this case, x bar is 0.1 minus this value will be 0 because we assume the null hypothesis is true. Right? We'll assume this is true. So this is 0 divided by standard deviation is 2.44 divided by square root of 64. You find out what that value is. That will be your test statistic. Then what you can do is you go to your t-score chart to find the p-value. So after you find your test statistic t, you can go to the t-chart and find the p-value and compare your p-value with your alpha. And if your p-value is greater than alpha, that means you're failed to reject the null hypothesis. And if your p-value is smaller than alpha, then you reject the null hypothesis. Then you make your conclusion, right? That's the process of using a formula to conduct the test. So here I want to show in more details about how to do it using StatCrunch. So here we have the StatCrunch. What you can do is go to Stat. Since we're dealing with the t statistic, so t-stat, one sample, and here is with summary, because we're given, the summary. The sample mean here is 0.1. Sample standard deviation is your S 2.44. Sample size here is 64. Okay, now the hypothesis test for mu, the null hypothesis test is mu is equal to 0, and the alternative hypothesis test is alternative hypothesis is mu is greater than 0. And let's compute. Alright, you can see the p-value is right here. Give you the p-value. It's 0.372. That's your p-value. Okay, so I'm going to write it down here. P-value. P-value is 0.372. Okay, now you compare this p-value with your alpha. It's pretty obvious that this p-value is greater than your alpha. So what does it mean? That means for this test, what is that? This is a right tail test, right? So for this test, this is your p-value. Your p-value is 0.372, and your alpha is 0.05, which is, this is your alpha. So if your test statistic is within the area of the alpha, that means you can reject the null hypothesis. But in our case, our test statistic is outside of this alpha, right? It's more closer to the center. Then we fail to reject the null hypothesis because our sample is not extreme enough to reject the null hypothesis. So here I can make the conclusion, I failed to reject the null hypothesis, and there is not sufficient evidence to support H1. So usually in the conclusion, you want to state what your H1 is. Your H1 is, let's go back to the problem, is that with the garlic treatment, the mean change in the LDL cholesterol is greater than 0. So I would just say the mean change is greater than 0, but really this is just your H1 in words.